Hi, Konstantin.
Hey, how you doing?
Good, thank you.
Wonderful.
How are you?
All right, let's. I'm good, good. Thank you. Let's give people 1 minute to join, and we will get started. Hey, Shaquille, how you doing?
Good morning. How are you?
Good, good. How are you doing?
I'm good. Thank you so much.
Thank you for joining. All right. We'll see if anybody else joins during the session, but I would like to start already. And the first thing I want to ask anyone if we have any questions that we want to discuss at the start. If there are no questions, we could go right into the cloud security posture implementation. Of course, it will be only the first pass, if you will, because the subject is deep and we'll need a few sessions to go through everything. Do you, Shaquille, for instance, do you have any questions that you'd like to discuss first?
Not at the moment. Yeah.
Okay, sounds great. All right, so let's get right into it. As we all remember, we work with we work on compliance and on GRC, right? In the imaginary organization called Orbis, who is building their own software for HRs. They're building their own HR platform, and they have like 45,000 customers, if I'm not mistaken. And the goal of our session today is to see how we can establish governance and ensure, and risk management and ensure compliance for the software or around the software that this company develops. Before we get into that, I would like to refresh our memory about the fact that we are viewing GRC through the asset management perspective. So the most important thing for us is operational assets and software code and cloud resources are all operational assets, right? And we remember from the previous sessions that in order for us to ensure proper governance across resources, taking SOC 2 standard or framework as an example to ensure compliance, we have split our work on 17 separate work streams. And one of the work streams that we have reviewed last time was HR. But today, the work stream that we're going to review is cloud security posture management work stream. And I can start with showing you the dashboard that every GRC specialist should have when ensuring governance and risk management and compliance for cloud security posture. And that dashboard actually fully corresponds to the 9-dimension framework that we discussed last time. Let me quickly share it with you, and we will So let's take a look at it. Again, Orbis is developing software, right? And we need to ensure that we establish governance across everything that is being developed and published. We will be looking today through the cloud security posture perspective. Basically, they are publishing their software in the cloud mainly, and they also have a mobile application that is published through the App Store and Google Play and is made available to the end users, to the consumers, right? So, but today we will focus only on the cloud side and everything that is touching it. So in order for us to clearly see how much work is there and to understand how we can approach governance and compliance from the cloud security posture perspective, we look at our dashboard and see who are those stakeholders within Orbis who we can work with, who will be our allies on ensuring compliance of the cloud hosting environment, and also all the associated processes. Marcus Webb, of course, imaginary person from imaginary company Orbis, is our CTO. We have a few DevOps and platform engineers. We also have one security engineer, Jordan, and ML AI engineer, Siddharth. And Sarah, she's a COO, CFO. We will get back to her with all questions related to data governance. But these guys are main points of contact when we work on ensuring the security of cloud environment and associated resources or assets around it. Let's see what are those departments which are in scope for this particular work stream. It's of course engineering and infrastructure, legal and finance, again from the data governance perspective, and of course the executive team. They always need to be informed about everything that is happening within the company. They're also responsible for policy approvals and for all those for the establishment of all necessary processes like incident response and things like that. Basically, executive team is always there with each work stream. What are the policies, security policies that are in scope of this work stream? Is of course the access control policy, because we have to establish access control to our cloud environment. Secure development policy is a touching policy. It's actually touching the cloud environment from the CI/CD perspective. It's actually the way how software is being published through. If developers implement all the security practices during their work and implement proper CI/CD procedures, continuous integration, continuous delivery, right? Then the software is actually the secure development policy governs all those procedures, and it also touches how the application is being published or software is being published to the cloud environment. Of course, we look at information secure roles and responsibilities, understanding who is responsible for the security of things. Operations security policy indirectly applies, but of course it applies mainly because it speaks about change management, security monitoring, and vulnerability scans. It could be split into like company operations security policy and then cloud operations security policy. It does not really matter how it's structured. The most important is that the policy has all the necessary rules and statements that define how company security operates its assets, including the cloud environments, right? Cryptography policy applies because it actually depends on what market the company serves. If it's a regulated market, let's say DoD or the government, then special cryptographic protocols have to be implemented, like FIPS 140-3. If it's a commercial environment, still it's important that all data is properly encrypted at storage and in transit, and that the most modern, the least vulnerable cryptographic keys are used to encrypt the data. Maybe you've heard that MD5 was compromised, right? So it's no longer used in SSL certificates. RSA. I'm messing things up. So MD5 was compromised, but RSA was also compromised, and so the new generation of SSL certificates are using ECDMA, or sort of similar name of the cryptographic algorithms. ECDM. Sorry, I need to look at the proper naming, but something along those lines. But the main goal is, and the next generation of the cryptographic protocols will be, of course, those that are resistant to, quantum computing, because quantum computers can crack existing cryptographic keys and real quick, within minutes, although for the normal computer it would take years or even tens of years to do so. So the shifts is happening, and it's important for the GRC person to actually oversee all that and make sure that all the new developments that are proven to be future-proof are implemented, right? Incident response plan, of course, is an important part of this scope, because actually, as we publish our software to the cloud, there are two types of issues that we need to watch for: the operational incidents and the security incidents. Operational are those related to application crashes, outages, and things like that, or misbehavior. And security incidents are those when attackers try to break into the environment, steal data. So it's data exfiltration, data leakage, and basically when the malicious actors are breaking into the environment and damage applications, or mainly data, because data is the most important piece. And when we establish governance across software and information systems and cloud environments and everything, the main thing that we should care about is always data, because data is the most valuable piece. Software, of course, is valuable, that is serving data, but especially in AI era, it could be really quickly redeveloped or copied or whatever, reconstructed. And it has never been a big of an issue. But the data is the biggest concern, and we also always have to worry about it. Information security policy applies here indirectly, because it's like an umbrella policy for everything. And the business continuity and disaster recovery plan applies by its disaster recovery part, mainly, because the company needs to know to actually promise to itself how quickly they can recover systems from the disaster, right? And it should be in the plan. It should be properly structured and well tested as well. So in terms of policies, I believe is the whole set. If anything is missing, let me know. Then let's look at the processes and procedures in scope. Here in this work stream, we have to care like about everything because the cloud environment is so multi-dimensional thing. We need to care about access control and access governance, right? Vulnerability management. So our servers, I mean, if we are only speaking about the cloud environments, our servers, our software code should be security scanned. It should undergo static scanning, like when the code is being developed, but it's a little bit of a different work stream. It's a software secure software development lifecycle work stream. But again, and it should be scanned at runtime. All the servers have to be regularly patched. All the incidents have to be properly logged and taken care of, and things like that. Security monitoring is another big space here, procedurally and process-wise, because we need to establish all the monitoring dashboards for our software. We need to set up all the necessary alerts, again, for both operational and security, and security realms, if you will, like security domains. So when, let's say, the software experiences an outage, we should receive an alert, as well as when somebody tries to scan the port and plans an attack or exploits any vulnerability in our operating system or anything, we should also be receiving alerts and processing them, right? For that reason, the monitoring, it only says security here, but I would add operational and security monitoring as one big thing, because both have to be covered. Another process in scope is data protection and backup. Data protection is about data encryption, data leakage protection, right? And then it's about data recoverability. So basically it throws back to backups. So we need, the rule of thumb is to make daily backups. If your database is huge, then we are talking about incremental backups if the database is reasonable size. We're talking about full data backups. So the system is fully recoverable from just a single backup. Or of course, if it's a huge system, there should be a well-defined disaster recovery procedure, right? That establishes a really implementable, let's put this, or executable process for recovering data from multiple incremental backups. Then incident response and recovery is about kind of similar thing, but from a different perspective. Incident response is like every system outage has to be logged and triaged and processed. From every incident, the most important thing that we take from every incident is not the incident itself, it's not the root cause, it's not the actual recovery procedures that we implement in order to restore the systems or protect the environment. Is the lessons that we learn from each incident. The lessons that we learn from each incident is the most important asset that you may have, because through those lessons, and if you document them well, and if you act on them, you improve significantly as the organization. You grow quickly, you become more and more mature, your products become more and more durable and trustworthy. Configuration and compliance is an interesting domain here. So as we publish our software to the cloud environment, as we organize the cloud environment, this is basically what is called the CSPM part, cloud security posture management, meaning that as you organize the cloud environment, you implement a huge number, but a reasonable at the same time number of security controls to protect the whole foundational, your whole cloud environment as a foundation, and then all the services that you are running inside your cloud environment as the next level, and all the software that you are publishing to the cloud environment that leverage those services as the top level, let's put it this way, right? So it's like a 3-layer cake. And at each of these layers, you have to implement proper foundational security controls. Like, for instance, if we speak about the cloud infrastructure, you want to, first of all, establish all proper security logging across your whole cloud environment using, I'm an AWS guy, but you could translate that to GCP and Azure. There's a thing in AWS called CloudTrail. It's basically the logging, the centralized logging, audit log about the whole environment as a whole. So you can see all events happening inside your cloud environment, right? This is one of the foundational things that you have to establish. Another thing is you need to initialize a set of encryption keys that will be used to encrypt, decrypt data. And you want to make sure that those encryption keys are actually isolated. They have their own purpose. One encryption key is used to encrypt and decrypt, for instance, the main database. Another set of encryption keys is used to encrypt and decrypt data in the cloud storages. The third set of encryption keys is used to encrypt and decrypt data on the disk volumes inside your cloud or virtual servers and things like that. These are the foundational things, right? Then the second piece is the service layer, as I mentioned. Like when you spin up servers or when you define the server configuration, you need to make sure that all your disk volumes are encrypted, that operation system that you select for your servers is actually well maintained. For instance, if you would spin up servers on FreeBSD, which is not maintained for many years now, I mean, probably it is, but it's not well maintained, right? Or on the old version of the Linux operating system, you will not be receiving the necessary security updates. And for that reason, your servers will be vulnerable for the hacker attacks, like obviously, right? So this is on that layer, you select security, you implement security controls that are actually establish a second layer of protection, if you will, right? So the foundational layer of protection is your cloud environment. The second layer of protection is your server infrastructure and whatever service infrastructure that you're using. If you're using serverless, if you're using services related to, I don't know, messaging, AI models, serving AI models, AI training, or things like that. Each of those should be properly configured. And there is a set of foundational controls or security measures that you have to apply. And then the third level is your applications or your software. How many applications it consists with. Actually, you have to apply security measures to each one of them. And it includes secure code scanning for vulnerabilities, scanning of third-party libraries for vulnerabilities, detection of security weak points in code that could result in a vulnerability and things like that. So this is the third layer of protection that you establish, right? And as a GRC specialist, keeping all that in mind is a big, energy drain, if you will, right? Because you have to look into so many places. And for that reason, I'm showing you the dashboard that actually combines it all together in a single place and gives you an overview from a single perspective at all those different aspects. And as we started with people, stakeholders, right, who are helping us to implement all that within the organization, the departments that we can interact with to work on those things, the policies that are in place for all those big and small security rules or operational rules, and then the processes and procedures. And within each process and procedure domain, there are certain risks associated with that domain. This list is not comprehensive. It's only given here as an example, but you can see that the risks listed here are real. One thing I didn't mention is when you establish the configuration and compliance, when you establish that for your cloud environment, the three-layer cake that I mentioned, there are multiple things that help you do that. It's not that you're alone in the world trying to figure out what are the right controls, what are the wrong controls. There are many what is called benchmarks that you can run to validate your cloud environment, your service and server environment, and your application environment. Let's call it the environment as well. Your application for for satisfaction of for the best practices. Let's call it this way, for the security best practices. And for the cloud environment, there are what is called CIS benchmarks that you can, it's actually a set of checks, compliance checks that you can run against your own cloud infrastructure that give you an overview of what is already implemented from the security perspective, what is missing. CIS benchmarks are the, I would say, the foundational level benchmarks. If you need, it actually depends on what compliance standard you're trying to implement in your organization or for your products. If it's SOC 2, for instance, CIS benchmarks will be enough to show you what's missing and you just close those gaps. But let's say if you implement a more secure environment and you are selling your software to government or to military, you have to work with a different set of benchmarks. And another level that I know of in the federal space is STIG. These are STIGs. So what is good about those security checks? They also give you some recipes and sometimes even the actual patches that you can apply to your systems to implement the security, to close those gaps, to implement those security measures that are missing. And we can actually, we can actually talk more about it, but it's all, so there are so many small pieces that we need to keep track of that it's important that we have, the dashboard that helps us see all that and, that we have actionable insights on what are those risks associated with each domain, what is those compliance checks, which are not actually shown here on the dashboard, but they should be. What are the SLAs on certain operations or incident response or whatever incident handling, right? SLAs that we commit to, having this observability is really helpful. Yeah, go ahead. Mm-hmm.
Meeting is anything.
Shaquille, you wanted to say something? Sorry.
No, sorry.
That's okay. All right. So we'll look at the processes and procedures, and the other thing that we'll look at is the actual list of assets in scope for our work stream here. Our work stream is cloud management, right? Cloud security posture. So it's obviously all the cloud accounts, and everything inside of them, like databases, virtual networks, data storage, whatever services that we're using to operate our software, CDNs, the monitoring stack, the access control configuration, the remote access, points, and of course the data that resides inside our cloud environment, and all the applications. All that is in scope for the cloud security posture work stream. Do you have any questions on the observability part here on, how to, it's a high level picture at how a GRC specialist could build themselves the observability across the cloud security posture implementation. And from here, we can get into reviewing particular security controls, that are needed for the cloud environment. Please let me know if you have any questions about this first, and we'll switch to the deeper dive into the cloud environment after I answer your questions, if you have any.
No question.
One quick thing, Constantine, what kind of security would the cloud vendor give us if we, when we're using their service?
So the cloud vendors, they operate on what is called the shared responsibility model, okay? The shared responsibility model means that they guarantee the security of their control plane, first of all, the security of their data centers. So basically, they cover all the physical security controls for us. They guarantee the security of the what is, sorry, I forgot the name. So basically, they are managing their server infrastructure through the virtualization software, which I forgot the name for, but actually they have the infrastructure, the software layer built on top of their servers that logically separates physical computing from the virtual computer. So basically that virtualizes the whole environment, right? So let's say they have 1,000 of physical servers in the data center, and their virtualization software makes it a 1 million virtual servers out of it, or a different number of virtual servers based on how many resources each customer needs, right? So what they guarantee is the security of this virtualization layer that is very secure and tamper-proof and everything, but they do not guarantee a security of every virtual server that you create inside their environment, because you choose which operating system you want on the virtual server, You choose what software you want to install on that server, and it is your responsibility to ensure the security of each virtual server. So, so going back to the shared responsibility model, they guarantee the security of the cloud environment, but not necessarily your cloud account, not necessarily servers that you create inside that account, not necessarily the security or of the service configuration that you apply to any service that you're using within that cloud environment. So let's say if I use AWS end user messaging and I decide to create a Lambda function that makes it possible for me to just, to send a text message to anyone by just submitting a form on the web. If that form is not protected and anyone can send a text message to anyone, right, in the world, and I suffer from it because I have to pay for all those, but it's my responsibility that I did not protect the web form, the Lambda function, or whatever else, the service itself, from the possibility of this vulnerability to be exploited, And it's not AWS, not Azure's, not GCP's responsibility that I don't care about the security of my own environment. So they guarantee the foundational security. Everything else is our responsibility. Okay.
Thank you.
Mm-hmm. All right. So let's get a little bit deeper into. Let's actually start with. Let's look at the risks associated with the cloud environment real quick. The key risks, let's put it this way, because the actual number of risks is huge. But if we have the observability dashboard, we will be able to actually manage all of them. I have a list of like 286 line items, the security controls, let's put it this way, that we need to establish within each cloud account or within each cloud organization. I will not bother you with that list. And I'll send you the link to where all those security checks are actually well documented, and you can just ask whatever Claude or whatever AI you're using to build a security scanner on, based on those rules. But the key risks, we need to look at them here because they matter from the GRC perspective, right? And again, I want to say that the other risks that are not listed here are not less important, but these are kind of the key ones, right? So when there is a cloud account or the cloud organization account that has no MFA, we are risking this account because it could be taken over by the malicious actor. So it's kind of, when I look at the cloud environment security, I always look at it from the perspective that, the main question that people ask when they implement cloud security, and it's a very valid question, is always, what are those priorities? What should I do first, second, and third, and next, and whatever, right? In order to protect my cloud environment. And the first thing I say, okay, think of it this way. You have a perimeter, you have a boundary that you need to protect. How do you protect it? Of course, the first thing that you establish is the boundary protection itself. Your main concern from, priority number one is to make sure that your account is secure, that no one can break in, right? That ports are closed on all servers, that virtual network or the physical network is properly protected by a firewall, that all traffic is inspected, that that it's a basic or the foundational level of protection. You have a good password to your account. All of your accounts have good password, have MFA. The virtual network has a firewall. All ports are closed except the HTTP or whatever else is needed. If you're a gaming shop or whatever, of course you need some different traffic flow. You have different traffic flow rules. You need to open UDP ports and certain TCP ports at other locations. But I mean, the goal is to minimize the blast radius, right? So basically, you only have 1 or 2 ports open to the world, and you can establish a good control or monitoring over them. So the next priority is you protected this stuff, start monitoring it. Invest into building, monitoring, and alerting system for yourself, right? Priority number 3, look at the server security, operating system security, and of course on the side, not on the side, but in parallel, implement code scanning for vulnerabilities and everything. As soon as you ensure the security of your operating systems, of your code, make sure that the process you use, this process, the CI/CD process that you use to publish your software from the code repository to the cloud environment is done in a secure manner and a controlled manner. Sometimes security is less important than control. Sometimes control is more important. Sometimes security is more important than control. But usually they should go, both should be configured on par or set up on par, meaning that you need to know when you need to establish control over publishing your software to the cloud, right? And at the same time, you should do it through the secure connection. And before publishing, you need to establish certain quality and security gates. So vulnerable software or non-operational software cannot get into your cloud environment, right? So the first risk, of course, is the account protection, and it's listed here, right? Then network layer protection, security groups, firewalls, all those things. If it's not established, ports are open, IP addresses are discoverable, and things like that, you are at a big risk of being attacked. And the network scans, the network type of attacks are the most popular, the most well-established, hacker attack. How do you say it? Hackers have established it over the period of the last 30, 40 years, right? So these tools that they use, the techniques that they use to break into your environment are very well thought through, very well designed, are sophisticated. You cannot count on your own luck, because also because every port and every system that is exposed to the broader internet it will be hacked within several weeks at least, if not several days, right? So it's important to protect your network. Then data encryption, unencrypted data at rest. I would say it's a key risk, but for me, the biggest risk is unencrypted data in transit. Of course, we have switched to HTTPS invisibly over the past 10 years. You cannot believe that even in 2005, even 2015 maybe, there were a huge number of websites across the internet accessible through the insecure HTTP protocol, which is absolutely insane. You can hack them like that. You can intercept passwords and everything, and all data that is flowing in or out of that website. So I'd say, yes, encryption at rest is important, but encryption in transit is the most important, more important than that. But I do agree with the key risk here that an encrypted database, even somebody breaks into your environment, if you implement proper data encryption practices, if you separate encryption keys and use them for different purposes, you're making the life of a hacker so much more complicated. They cannot access things, and they can only they will be damaging your environment, but most importantly, they will not be able to read your data, and data is usually the biggest concern, right? Yeah, so this is the canonical issue. Storage buckets exposed to the internet. Again, it is somewhat a little bit separate from the network configuration issue, but in fact, it is the same. You should do it like alongside with the network configuration, but there's been so many incidents and data breaches and reputational breaches related to the bucket exposure to the public internet. You cannot believe how many big companies experienced. I don't know. All data was sucked out of those companies through those buckets, and it did so much, so much bad things to the world in the past 10, 15 years. We couldn't even imagine. Then, of course, what is touching the cloud environment is CI/CD, right? So compromised pipeline. This is why I actually mentioned that this part here from the code repository to the cloud environment has to be secured. What happens is, if you think about it this way, cloud environments for a long period of time, again, they started appearing back in 2000 something, 9 or 8, and it's been almost 20 years, right, of the cloud era, and maybe 20 would be the right way to say. What they started with, their primary security control. Well, actually, how they implemented security from the beginning, they gave you 2 security keys to access the environment. On AWS, it's actually called the AWS security key and secret key, whatever. Just a pair of keys. At the time, it was a secure enough approach. A pair of keys is much better than 1 key. But what happened is, if this key is static, or this pair of keys is static, like you generate it once, you put it somewhere, and that somewhere, that other environment gets hacked over time in 5, 10 years, whatever. Now the hackers have your 2 keys, which give, usually, because of how the people didn't actually care about the principle of least privilege at the time, which is now we're caring about. So those security keys were giving full admin control over production, let's say AWS or Google or Azure environment. And it's a time bomb that has still haven't blown fully yet, because of how many CI/CD pipelines rely, for instance, on this pair of keys that has been generated back in 2010, and the software is still being deployed to the cloud using that pair of keys, and this pair of keys was already known to the hackers, because you cannot count on it not being known, because every system has been hacked at least once already. But because there are so many systems in the world, their significance or value is so different that hackers may not have had the chance yet to actually rob you for the data, right? Or make damage inside your environment. But it's a time bomb still. And with the AI in place right now, it accelerates a lot, and we will be seeing more and more and more cloud environment. How I say it? Hackers will be breaking into cloud environments and making damage at a great scale, because there is still a big number of companies that haven't taken care of rotating those keys over time, or haven't reduced the privilege inside the environment associated with those keys, right? And for us, as we work in the modern world, the principle of least privilege and the use of dynamic role-based keys instead of static keys now becomes a norm. And but we should actually know that it is important that we follow that best practice. Otherwise, the damage to our environment is inevitable. So basically, it rolls back to number 37 here. Overprivileged roles. Blast radius of a compromised credential is catastrophic. We just discussed all that, right? And the other thing, a big risk, not only it's categorized here as AI related, I would say let's talk about it a little bit more broadly. Data leakage or PII leaking, PHI leaking, and other stuff, it's all possible through public storage buckets. It's all possible through overprivileged roles, unencrypted databases or snapshots, open ports, and everything that we have just discussed. And of course, the new AI opens up the new category of issues here, because whatever it's been trained with can eventually be exposed through the inference. And if you ask AI to do certain things, and regardless of how many guardrails have been established, there is still a big risk of that data to be exposed. So we need to talk about AI security more, and we will have a few sessions dedicated to that specifically, because AI security and data security in general is a huge topic. And it starts with proper data labeling, data classification, right? And for that reason, I think that data handling policy also applies to the cloud posture management workstream, although it was not listed there, but I will add it there. So we do data labeling to make sure that we know what data is about what, right? Then we do data classification to figure out what data is public knowledge, what data is confidential, what data is sensitive, what data is protected by law, and things like that. And then data labeling, data classification, data encryption, and then the data masking, data anonymization, specifically for certain data processing practices, and of course, AI training. AI should be trained on anonymized data or masked data. It must not know names. addresses, emails, phone numbers, and things like that, right? I'm not even talking about the medical records. It's out of the question here. So quick recap of everything that we've looked at today. Identity and access management, fully related. I mean, it's in scope for the cloud environment. Data and encryption, change and vulnerability management, operations and continuity. It relates to security monitoring, incident response, and things like that. We touched CI/CD, security, and compliance a little bit today. The AI complication, again, it's a separate subject for the separate discussion. SLAs, it's important that the company makes some commitments on how quickly the new account is provisioned, how quickly the data, I mean, for how many, how frequently the data is backed up, what are the data retention rules, how frequently the secrets are being rotated, on the data restoration procedures should be in place and they should be tested, and what are the SLAs on the incident response, how to determine the severity of an operational or a security issue, how quickly to respond to it, and things like that. All that should be in place, and it's in hands of the cloud ops team or cloud SRE, site reliability engineers, depends on how it's called in different organizations. And it all rolls back to the management, of course, and GRC to ensure that the governance is established. So we have looked at the cloud environment. The suggested topic for the next session is access controls, because we reviewed HR workstream, we reviewed IT security workstream and cloud security workstream. Access control is also multi-aspect, multidimensional. I suggest that we review it next time. But if you want something different, like let's say secure software development practices first, we could do that first and then switch to access control as an overall umbrella, let's say work stream covering it all. You just let me know. It is just a suggestion for the next topic that we discuss next time. I think I'm done with my talking. Please ask me whatever questions you may have today, and I would be very happy to hear your thoughts on the next topic.
Constantine, I have one quick question regarding one of the cryptography related issue that we talked about.
Mm-hmm.
Okay, so I know you mentioned about the quantum computing could, break into those, all those, modern cryptographic, tools, right? So the thing is,
Mm-hmm.
let's say if I have a password long enough, let's just say 14 character. I know sometimes it's unreasonable. Let's say 14 character, and I have SSO, right? Would that also be easy for hacker to break in?
In the quantum computing era, I would assume it is. Yes, because it breaks even the the encryption algorithms, cracks them like nuts within minutes.
Oh my God!
So your password is not saving you. So there is a big wave in in the implementation of post-quantum, that this is how it's called, encryption algorithms and approaches overall in the industry, and you can read more about it. I can try to provide you, supply you with some resources, but I haven't actually touched this subject deeply.
Okay.
Yeah, but yeah, I mean, the password will not save us.
Okay. Sad to hear that. Okay. Cool.
Yeah.
All right. And also, you mentioned that you're gonna give us access to the tools.
Yeah.
Okay.
Yeah, I know you're asking about it for many times now. Yes, and I'll make sure to organize that access within the next few days and give you access to everything. Yeah.
Okay. Thank you so much. No pressure. I just just
Mhm.
wanted to touch base with that.
Yeah.
But thank you so much.
All right, guys. I mean, I hope it was helpful, and
Absolutely.
I'll see whether access controls will be the next session, or we will first touch these secure software development practices, because I still think that access controls is like an umbrella topic for all of those. And I hope to see you guys next Friday. And please keep talking to me on Reddit, via email, and whatever else other channels you have, asking questions, requesting materials, and things like that. I would be happy to provide all that. Okay, and giving me your
sure.
feedback. All
Sure.
right.
Sure. Thank you.
Thank you, guys. Have a
Thank
good.
you.
Thank you.
Have a good weekend.
Good weekend, guys.
Thank you. Thank you.
Yep.
Thank
Have
you. It
a
was
great
good seeing
weekend.
you all.
Bye.
Bye-bye. Thanks.
Bye.